Hello, I am Erdem from UVision. In this video we will learn source transformation. Source transformation is a very powerful tool for us to simplify circuits, and it has two cases. First case is to transform a voltage source into a current source. Second case is to transform a current source into a voltage source. I will start with the first case. Source transformation lets you to transform a voltage source into a current source if and only if you have a series resistor connected to that voltage source. Okay, that's the only rule of the source transformation. You must have a resistor connected to that voltage source in series. After transformation, what you get is a current source and a resistor parallel with the current source. Alright? You may ask that what will happen to values? Will the resistance value remain the same, or the voltage supplied by this voltage source and the value of the voltage, will it be equal to current supplied by this current source? You're right. There are some transformation rules. And the thing is that resistance value does not change. It remains the same. When you make the transformation, you will not play with the value of the resistance. Okay? And the second thing is values of these sources. They are not equal. For instance, if this is 5 volts, this is not 5 amperes. There's a relation, and I will write it down. I1, current supplied by the transformed current source, is equal to voltage supplied by the voltage source over R1. For instance, this is 5 volts, this is 2 ohms, and then current supplied by the current source is 2.5 amps. Alright? So this is the mathematical relations between the components. And another question is that how will I determine the direction of the current source? Well, that's pretty easy. And assume that this is your voltage source, and plus sign, positive sign, indicates the tip of the arrow, and minus sign is the tail of the arrow. Alright? That's how you determine the polarity. So in this case, plus is the tip of the arrow, minus is the tail of the arrow, so your direction is upward. So easy. Let's say that this is your voltage source and you want to transform it into a current source. Then your direction is to the right. Positive is the tip, negative is the tail. Okay? So easy. And what I want to point out in this case is that please be cautious with the resistance. If you have a circuit like this is your resistance, this is another branch going, this is another branch going, okay? If you can't find any resistor in series with the voltage source, you cannot make this transformation. If this is the case, and you cannot reduce them into one single resistor that is in series with the voltage source, you cannot make this transformation. Not valid. Alright? Please be cautious with this structure. Okay? Second case, transforming a current source into a voltage source. Source transformation lets you to convert this one into a voltage source if and only if you have a resistor in series with the current source. Alright? and when you make the transformation you get a voltage source and a series resistor. Now what will happen to values? Let me write them down also. Resistance again the same. You won't need to concern about the resistance. It will remain the same. But the current supplied by this PAL and voltage supplied by this PAL will not equal. There is a relation, mathematical relation between them, and VA is equal to IA times RA. IA times RA. Assume that you have 2 amps, you have 5 ohm. You will convert this into a voltage source. Your resistor will be 2 ohms and your voltage source will be 10 volts. I think I have told you that this is 5 amps, right? If you multiply 5 by 2 you get 10. And the question is that how we will decide to the polarity of the voltage source. Assume that this is your current source. Tip of the arrow is positive and tail of the arrow is negative. So this is how you decide to the direction. Alright? So easy. This is your current source, it's to the right, and this is your positive terminal, this is your negative terminal. So your current source will be like this, and connected a resistor in series, and whole port will be like this. And I am thinking that if I have forgotten something. Yes, I have forgotten something. These transformations are also valid for dependent sources. I won't discuss them explicitly. I will just state you. And assume that you have here a dependent voltage source like this, and with value Vs. You will convert it to a dependent current source like this. Then the resistor again is the same, and the relation between current source and voltage source is again the same. So IS is equal to Vs over R. Same relation, and same relation also applies here. Assume you have a dependent current source and you want to convert it to a dependent voltage source. Resistance again the same, and voltage value of this PAL simply IA times RA. Okay, so that's all for this video. Thanks for watching.